lesson 2. By the way, I just this morning tweaked the software. I'm hopeful now the sound will synchronize properly. Those of you that have watched my video lessons, apparently the further you go, the worse the sound gets. The real solution is I need to get a faster, better computer, and that's on my list of things to do. But I think when I'm showing a video, recording a video, and teaching, I'm overclocking the machine so much that the exhaust that comes out right here can burn my hand. It's that hot. So it's really the laptop, but we'll try. So far, we've learned how to solve for the missing side of a triangle using the Pythagorean theorem, and my abbreviation for theorem is THF. Pythagoras. Heck, I'll even write it up here. A squared plus B squared equals C squared. This only works when we have two things, though. The hypotenuse and one leg, one side, or two legs. Shalom, what we're really saying is you got three variables in this equation. You need two of them before you can find the third. Because it's been a few days, let's jog our memory here. Here's an example of a word problem. I would consider this one fairly difficult. With the diagram, I would consider this fair game on the test, but Joel, as a fairly nasty question. I wouldn't be saying, hey, this is number 1, and expecting all of you to get it. Okay? Joel, it says this. A builder is about to cut rafters for the roof of a house. There's the roof. The width of the house is 12 meters. Why don't I cleverly label that? Because now the question's no longer blank and I feel better. And he has to make the roof 2.5 meters higher in the center than on the sides. I'm going to put that 2.5 on my diagram somewhere. Where am I going to put 2.5? Oh, on the dotted line. I like that. 2.5 meters. If the eaves, which may be a word that you don't know, overhang 0.5 meters, well, the fact that they said overhang might help me figure out what the eaves are. What are the eaves in this picture? What overhangs? I'm going to go like this. Yoink, right there, and I'll say that is 0.5 meters. Find the total length of the rafter he has to cut. I think the total length is that. Although I don't think I'm going to find that directly. I think I am going to do one more thing, Zach. I think I can put a 90-degree angle right there. Yeah? Because I'm looking for Pythagoras stuff, and that's the only triangle, and it is a 90-degree triangle. Anybody have any idea how I can find L? It's going to take a couple of steps. Yeah. Yeah. I'm going to put an X, I think, right here. But, ready, Nicole? How far from here to here? How far from here to here, then? No. How far from here to here? How far from here to here? 12. How far from here to here? Ah, I don't need to put an X on that side because I can reason. Looking at the diagram, I think the roof is in the middle. Is that okay? So I'm going to put a 6 right here. And in fact, I'm going to just redraw this triangle to make it a little easier. I think it's 2.5, 6, and X. Now, that's not going to get me the complete answer. Once I find X, which is the length of this red line, what will I have to do to find the whole length, including the overhang? Add 0.5. There's my steps. Okay. Oh, Emma, did I write Pythagoras up here? Then let's go straight to plugging in numbers. This X, is it the hypotenuse or is it a leg? So where is it going to go in the A, the B, or the C? Okay, so I'm going to go like this right now. 2.5 squared plus 6 squared equals X squared. I said to you, I have no problem if you go straight to that line. Now it's calculator. Rob, square root is right here, second function x squared. And for those of you that have the graphing ones. Natasha, I don't know where square root is on that one. Hopefully you can find it. It's going to be 2.5 squared plus 6 squared equals square root. You get x equals 6.5. Don't forget the square root. Am I okay, Colleen, if I just right now go x equals 6.5? You know the steps that I did? I said to you, yeah, I am good with you showing one line and going straight to the answer. In fact, Joel, in your homework, I'm almost okay with you showing no work and going straight to the answer. Now that means you could just cheat and copy the answers from the back. I'm going to trust that you're not dumb enough to do that, thinking somehow that that won't come back to bite you on the test, right? Meters. So what's L? Ready, Nicole? How far from here to here? What did we just say x was? So, yeah, you're right. 6.5. How far from here to here? So what's the total length? Right? Which, can you in your head? 6.5 plus 0.5? It is 7, exactly. Let's even go 7.0. We'll go to 2 sig figs if you're talking science, since they seem to have... Anyways, I wouldn't take marks if you just said 7. But exactly 7. Sam, bring back Pythagoras, jog your memory a little bit. Okay. What we're going to look at today and for the next few days is what do we do when we aren't given two sides, when we're only given one side and an angle. In order to do that, we need to be able to know a few terms in basic trig. And the first is we have to be able to name sides. The slanty or the longest side always across from 90 degrees. This one you already know. This is the hypotenuse. I'll often use a lowercase h for that. Then we have the side opposite the angle that you know or want to know. Underline the word opposite. Another word for opposite is across from or facing. And in fact, we call it the opposite side. Does anybody besides Rob remember what we called the third side in trig? We had hypotenuse, opposite, and, do you remember? Adjacent. What does the word adjacent mean in English? Right now, Kiara and Jacob are adjacent to each other. It means beside. So that's how I remembered it. I know the hypotenuse is always a slanty one. If the other side is beside the angle that I'm looking at, it's the adjacent. No S in there, Mr. Dueck. Adjacent. We abbreviate these as H, O, and A. Opposite, adjacent, and hypotenuse. And you do have to be able to tell Zach which side is which, but it all depends on the angle that I give you as your reference point, as your starting point. So here we have angle, that little symbol is an alpha. We traditionally use Greek letters for angles. Why, Nikki? It's math shorthand. I use X and Y for graph points quite often. If I ever see traditionally a theta, which is the letter we use for an angle, I right away know it's trig. Greek letter alpha says, find the length of the side that, okay, what's the hypotenuse in this triangle? How long? 13. How long is the side adjacent to alpha? 5. How long is the side opposite to alpha? 12. Opposite, facing, adjacent, hypotenuse, always the long skinny side. Example 2. We have a 9 by 12 by 15 triangle. Okay. Which of those three sides is the hypotenuse? How long? Nikki. You are correct if you said 15 under your breath very, very quietly. Which side is opposite to, you can call that an E, it's an epsilon. which is in this corner right here. Nikki, which side is opposite to this corner right here? Yeah, opposite means facing. Nice. Oh, Nikki, we're changing angles. Now we're sitting at beta. Which side is adjacent to beta? Remember, adjacent means beside. Now, Nikki, technically there's two, except we can eliminate the 15 because the 15 is always the hypotenuse. So, Nikki, which side is adjacent to beta? Absolutely. And then for some reason, when I printed it, it added an extra line on the next page. So opposite to beta is what? Joel. Here's beta. Which side is opposite to it? How long? 9. Or are you a German student saying no? No, never mind. Paul's not here. That joke would have been better a little while ago. It says, now we're going to look at the 3 primary trig ratios. If I had more time, I would walk through this. It says it wants us to look at the 3 triangles. Here's triangle 1. Here's triangle 2. Here's triangle 3. Let me erase those now. But those are the 3 triangles. They all share the same angle at the base. Tanner, if you were to very, very carefully measure this length and divide it by that length to like 2 decimal places, you would get a decimal answer. If you were to very, very carefully with a ruler measure this length and divide it by that length, opposite divided by hypotenuse, you would get the same decimal answer if you had a super accurate ruler, Nikki, as you got before, Nicole. If you were to measure this opposite divided by that hypotenuse, you'd get the same decimal. In fact, a long time ago, people noticed that these ratios, these decimal answers, keep appearing, and we gave them names. The fraction opposite divided by hypotenuse is called the sine. Spelled S-I-N-E, abbreviated S-I-N. The other 2 trig ratios, cosine and tangent. There's actually 3 more. They're the reciprocal trig ratios, secant, cosecant, and cotangent. You don't have them on your calculator because you don't really need buttons for them, and they're not used very often. In fact, anything you can do with secant, cosecant, and cotangent, you can do with sine, cos, and tan. So we actually call these 3 the primary trig ratios, the main ones. Okay? The word ratio divides one number by another number. Sine divides opposite divided by hypotenuse. Cosine divides adjacent over hypotenuse. And tangent divides opposite over adjacent. And I'm willing to bet your teacher said to you last year, you don't need to memorize it. They gave you this handy-dandy little acronym. How many of you have never seen Sohcahtoa before? You've all seen that? What did it stand for? Actually, what did the S stand for? Do you remember? Sine. What did the O stand for? And then you had to remember the divided by part. Sorry, you got to remember something. Over hypotenuse. What did the C stand for? Keep going, Ashley. Cosine. Let's keep going. Emma, what does the T stand for? Tangent. How do you abbreviate tangent? That's what I was doing on Sunday at Newport Beach in the sun. Sorry. And tangent, as it turns out, is opposite over adjacent. In fact, what I do in the trig unit, almost any time I turn to a new page, Tanner, at the top, I write Sohcahtoa. Easy way to keep me from making dumb mistakes. So, having said that, I don't think your guys' number is photocopied or something like that. So if you want to copy out this top triangle, put a little curvy E and epsilon there, a little fish, that's an alpha, a little b, that's a beta, and it's 5, 12, 13. And now that we have those in place, I hope, we can start to, well, it says, find the indicated ratio in fraction form. It tells us beta, that's this angle right here. Rachel, sine, according to Sohcahtoa, is what over what? So if this is beta, which of these numbers is the opposite side to beta? And which is the hypotenuse? So the ratio as a fraction is 5 over 13. Yes. Hey, what's the cosine? Adjacent over hypotenuse. So what's adjacent over hypotenuse here? No, 5 over 13 was the sine. That was opposite over hypotenuse. By the way, we're on beta still, right? I moved down. Look up. I didn't move across. I moved down to here. We're doing all the betas first. So what's the, yeah, my bad. I should have made sure you knew. You moved across, which is logical. For some reason, I'm moving down. Cosine beta. So what's the cosine of this angle? What over what? Over. Yeah. And Rachel, let's finish this off in style. What's the tangent? That's opposite over adjacent. Yep. What's the 13? Is that the hypotenuse? Yeah, 5 over 12. Yep. Way to finish in style. You're awake now? Good. Excellent. Try filling in epsilon on your own. Try filling in these 4 on your own. Did your 4 stay on the page, or did the last 3 jump to the next page on yours? Did this fit on your page? Oh, okay. The previous class, when I photocopied it, for some reason, these 2, I guess, were right on the break, and they bumped one. Try filling in those 4 on your own. I'll do them up here slowly. You don't need to do tan beta and sine epsilon twice. For some reason, they appeared twice. Don't ask me why. So the questions that appear twice for some dumb reason, don't do those. Should be able to get them without copying. If you can't, you need to come in as soon as you can and figure out the difference between opposite, adjacent, and hypotenuse. That's fundamental to this unit. Is that okay? I got cos epsilon 12 over 13. 5 over 13, 12 over 5, and then I got 5 over 17, 5 over 17, 15 over 8, 8 over 17. Yeah, am I wrong? Cosine, sorry? Example 3 or 4? Example 3, cosine epsilon is, that's wrong, Mr. Dueck. And sine is wrong, Mr. Dueck. So those of you that copied it out wrong, right, copied it out from me, shame on you. 5 over 13, yes, Paige? And 12 over 13, yes, Paige? Good gosh, how the heck did I do that? Sloppy. Sine is what over what? It's opposite over hypotenuse. Cos is what over what? It's adjacent over hypotenuse. Tangent is what over what? It's opposite over adjacent. How can I remember it, Natasha? Sohcahtoa. Turn the page. What did I just say? Turn the page. You know what? Let's be smart at the top and let's write Sohcahtoa. And then we can... In fact, you know what? When you get your trig test, what's the first thing you would probably do at the top of your test? Why not? Right, Chelsea? Now, for a while, to find trig ratios, you would draw a triangle that had the appropriate angle. You would carefully measure the sides and then divide them. But this would be time-consuming, and it was fairly inaccurate. Luckily, someone has already done these, and they gave us these in the form of trig charts. So when I was in high school, actually not when I was in high school, when my parents were in high school, they were given a chart that had every angle from 0 to 90 degrees. It had the sine, the cosine, and the tangent to like 5 decimal places. And then when I was in high school, I was, Rachel, the first calculator generation, and you guys are part of the calculator generation. Your calculator has all of the opposite over adjacent, opposite over hypotenuse, decimal values when you divide them programmed in. So get your calculators out. Got a calculator here? Might have forgot it. Then you're going to have to swap me for one. What do you got for collateral? However, your calculators can measure angles in 3 different ways. They can measure angles in degrees. We just did geometry. How many degrees are in a whole circle? 360. They can also measure angles in radians. How many radians are in a circle? 6.28. Say what? Trust me. And it can also measure angles in gradians. How many gradians are in a circle? 400. So you want to make sure your calculator is in degrees. Most of you on your screen somewhere, unless it's a graphing calculator, Cole and Rob and whoever else has a graphing calculator, most of you on your screen somewhere, there should be a little D somewhere. If you see an R or a G, now is the time to get my attention. In fact, the odds are you have either a D or G button, which stands for switching from degrees to radians to gradians, or you might have to use your mode button if you have one of those. So let's see if we can use the calculator accurately. To find the sine of 30, if you have a good calculator, Natasha, you should be able to go like this. Now, mode, I'm in radians, Mr. Dueck. That's not good. Degrees. You guys are in degrees, I made sure. You should be able to go sine of 30 and press equals or enter. And you should get 0.5. Try it on your calculator. Sine 30.5. Okay, you're in a different mode. Anybody else, now is the time to tell me. I'm going to pause the video. So if you know the angle, Nicole, you just simply type the sine or the cosine. We're going forwards. We're saying, the calculator is saying, tell me the angle, I'll give you the answer. So find the sine of 30. We got 0.5, yes? Can you fill in the next 5 on your own to 3 decimal places? I'll do them up here, see if we get the same answers. Cosine of 15, 0.966. And try and round off properly if you can, please. .035. I know tan of 45 is 1. 0.966. I got B 0.966, C 1.428, D 0.035, E 1 exactly, and F 0.966. Yeah? Okay. For C, you put 1.43. Did say to go to 3 decimal places, so 1, 2, 3. It's okay. I wouldn't take marks off, but let's follow the instructions. Nicole, now let's address your question. The nice thing about the graphing or any of the calculators is they can go both ways. If you know the angle, it will give you the answer. If you know the answer, it will give you the angle. How do you tell it that you're going backwards, Nicole? What button? You said it earlier. Second function or shift or invert, whatever it looks like on your calculator. Usually it's a different colored button. So if you want to go back from the trig ratio to the original angle, just hit shift or second function, sine, cos, or tan. So on my calculator, it's second function, and let's do A together. It's saying the sine of some mystery angle was 0.0523. I'm going to go second function sine of 0.0523. And I get 2.99. You know what? How many degrees is that really, Kiara? 3 degrees. Try this on your calculator to see if you can get the same answer as me. Anybody who can't, now is your chance to ask. I will happily help you. That's what I'm going to do. It says to the nearest degree, right? 3 degrees. See if you can find the other 5 mystery angles. Yeah. I guess technically f is 3 degrees if I round to the nearest degree. It's 2.56. I don't really like rounding off that much. I'd like to write it as 2.6 myself. But that's okay. I got 12 degrees, 32 degrees, 89 degrees, 27 degrees, and 3 degrees. Nicole, you know what the most common mistake is? Kids can't remember when to hit second function and when not to. All I can say is practice in today's homework and just memorize which way is which. I've tried to use English to explain, well, if I know the angle, it gives me the answer. If I have the answer, I need to go backwards to find the angle, and backwards to me reminds me to go second function. That's kind of a backwards number. Hey, do me a favor. What's the tangent of 90 degrees? What happens? Get an error? Hey, what's the tangent of 89 degrees? Sorry? 57.29-ish? You know what? What's the tangent of 89.99? 2 nines after the decimal. Is it bigger? Okay, you know what? Let's try tangent of 89 point and then do 6 nines after the decimals. 89.999999. Bigger yet, Joel? In fact, the closer you get to 90 degrees tangent, the bigger your answer gets. You know what the tangent of 90 degrees is? It's infinity. Which, can your calculator handle that? Your brains can. I just told you it's infinity and you went, oh, okay, the biggest number possible. Your calculators crash. This is one of the many reasons why we don't just give you a graphing calculator in grade 1 and say, here, this does everything. There are certain concepts machines can't handle. They have real troubles with infinities and zeros in particular. Very last thing. Let's learn to solve for a missing side if we know the ratio of an angle. If I have an equation that looks like this, the sine of 45 equals x over 10, where 10 is the hypotenuse and x is the opposite. How do I solve this? I remember that it's over 1, and you can write that in your notes, and if you want to write that in your homework, you can, but if you're good at cross-multiplying, you might not need to, because you know how I'm going to solve this? I just told you. Cross-multiply. I'm going to get 1 times x equals sine 45 times 10. I'm going to write 10 times the sine of 45, and that's what I'm going to type in my calculator. Is the x by itself, Joel? Yep, then I can go straight to my calculator now. What is 10 times the sine of 45? Sine of 45, I think, is 0.707. You get 7.07? Double check me. Yeah, I got a few memorized because they show up. I know 45, 30, and 60 because they're nice angles. So what do we get? What does it say? Let's go to 2 decimal places. 7.0. What comes after the 7? Oh, so 7.07. B. Cosine of 31 equals x over 4.8. This is technically over 1. Tatiana, we cross multiply. Tatiana, what's 1 times x? Sorry? I think you're right. I couldn't hear you. Did you say 1x? And that's going to be equal to 4.8 times cos 31. Tatiana, I'm just going to write 4.8 times cos 31. Is the x by itself already, Tatiana? Yeah, then go straight to your calculator. What is 4.8 times the cos of 31? This one I can't do in my head. I don't know 31 degrees. Sorry? 4.11? What comes after the 1? 4, so round it off properly. Alexis, this is also over 1. Alexis, when we cross multiply, now this one's a tiny bit different. By the way, do you see the difference between the first two and this one? Where is the x here? Where is the x here? Here the x is on, here on the, it gives you a slightly different, one more extra step equation. Because when I cross multiply, Alexis, what's 1 times 12 in your head, please? And what's x times tan 83? It's x times tan 83. I just write it like that. And then Alexis, I ask myself, is the x by itself already? Say no. What else is over there? How would I move it over? What's happening between the x and the tan mathematically right there? So how will I move it over? X is going to be 12 divided by tan 83. You got to do one extra step. I'll be honest, a lot of my kids, especially in Physics 12, have memorized, oh, if the x is on the bottom, I end up dividing. If the x is on the top, it's just a straight multiplying. And they almost use it as a boom straight there. You can if you want to. What's the answer? 1.47? This here is going to become hugely useful for the next over the next couple of days. Trig has lots of neat applications once you can learn to solve a triangle. What's your homework? Number 1, that's just practicing writing the fractions like we did in our notes. Please notice that part of the question carries on to the next page for some strange reason, but it did. Oh, yours is on the same page? I can't figure out what's going on then. It's got to be the 2 different print drivers that I'm using, which is way more techie than me. Can you read for me? Do not circle number 2 because I'm not going to assign it. But Kayla, can you read to me the instructions? Fraction form, just like number 1. And then what? Oh, if you know the fraction, could you type it into your calculator and get the decimal? Yes? Well, then skip 2. 3, all. I want you to get fast on your calculator. 4, all. I want you to get fast on your calculator. Adrian, you may notice number 4. In number 4, I don't know any of the angles. Number 4 is going to be the shift or the second function button. Going backwards. 5 all. It says questions 1 to 4 will be marked in class. Those answers we'll go over in next class really, really quick. Yo. Almost. Can you let me finish my lesson first? Patience, young grasshopper. Okay. You've got a full half hour. You know what? I think this will take you about 15 minutes. Hustle. You have no homework at all. I assigned, I think, skip 2, right? Everything else skip 2 would be the short way to say it. Let me save my lesson.